Hey everyone! Big news in the AI image generation world this week. Alibaba's Tongyi Lab just released Z-Image Base, the open source foundation model we've been waiting for. If you've been following the Z-Image journey, you might remember when Z-Image Turbo dropped about a month ago and made waves with its incredible speed. Well, now we finally have the base model that the community can fine-tune and build upon. Let me give you some quick context. About a month ago, Alibaba released Z-Image Turbo, and it was impressive. We're talking sub-second image generation on high-end GPUs and the ability to run on consumer devices with just 16 gigabytes of VRAM. Turbo is a distilled version optimized for speed, using only 8 function evaluations to produce stunning results. But here's the thing, Turbo is optimized and locked in. It's amazing for production use, but if you want to customize, fine-tune, or really dig into the model's capabilities, you needed the base version. And that's exactly what dropped this week. Z-Image Base is the non-distilled full foundation model with 6 billion parameters. This is the raw powerhouse that Z-Image Turbo was derived from. Think of Turbo as the sports car version, optimized for speed, and Base as the full workshop where you can customize everything under the hood. What makes this release exciting is that it's specifically designed for community-driven fine-tuning and custom development. This means developers, researchers, and AI enthusiasts can now take this model and adapt it for their specific needs, whether that's particular art styles, specialized use cases, or experimental techniques. All right, now let's get into the practical stuff. I'm going to show you exactly how to get Z-Image Base up and running in ComfyUI. Prerequisites: installing ComfyUI. Before we dive in, if you don't have ComfyUI installed yet, make sure to check out my previous video where I walk through the complete installation process step by step. I'll link that in the description below. It covers everything from system requirements to getting ComfyUI up and running on your machine. Once you have ComfyUI installed, come back here and we'll continue with Z-Image Base setup. Step 1. Access the template. First, open your ComfyUI interface. On the left side, you'll see a templates option. Click on that, and in the search box that appears, type Z-Image. You should see the Z-Image text-to-image template pop up. Click on it to load the workflow. Step 2. Download the required model files. Now you need to download 3 essential files. These are the core components that make Z-Image work. Head over to Hugging Face and search for the Z-Image model repository. Here's the important part. There are actually multiple variants of these model files available, each optimized for different hardware configurations. For the diffusion model, you'll find versions like Z_image_bf16.safetensors, which is the bfloat16 precision version, and there may be other quantized versions like FP16 or int8 variants. The bf16 version offers the best quality but requires more VRAM. If you're running on a system with limited VRAM, check out the smaller quantized versions that are compatible with your hardware. The 3 files you need are: first, the text encoder, quen_3_4b.safetensors. This handles the text understanding part of the model. Second, the diffusion model, z_image_bf16.safetensors. This is the main 6 billion parameter model file. Again, check Hugging Face for variant models if your system needs a lighter version. Third, the VAE ae.safetensors. This handles the image encoding and decoding. Take a look at the model cards on Hugging Face to see the VRAM requirements for each variant. This will help you choose the right version for your specific hardware setup. Generally, the bf16 version will need around 12 to 16 gigabytes of VRAM, while smaller variants can run on 8 gigabytes or even less. Step 3. Organize your files. Here's where file organization is crucial. You need to place these files in specific folders within your ComfyUI directory. Navigate to your ComfyUI folder, then go to the Models subfolder. Inside Models, you'll need 3 specific folders. Place quen_3_4b.safetensors in the text_encoders folder. Place z_image_bf16.safetensors, or whichever diffusion model variant you downloaded, in the diffusion_models folder. Place ae.safetensors in the VAE folder. Your file structure should look like this: ComfyUI, then Models, then 3 subfolders. Text_encoders containing quen_3_4b.safetensors, diffusion_models containing your chosen Z-image model file, and VAE containing ae.safetensors. Step 4. Load the models in ComfyUI. Once your files are in place, go back to ComfyUI and look at the workflow that loaded from the template. you'll see Step 1, which is Load Models. This section contains 3 loader nodes. The first is Load Diffusion Model. Make sure it's pointing to your Z-image model file, whether that's z_image_bf16.safetensors or another variant you chose. The weight_dti should be set to default. The second is Load Clip. This loads your text encoder. Verify it's set to qn_3_4b.safetensors with the type set to Lumina 2 and device set to default. The third is Load VAE. This should point to ae.safetensors. If everything is in the right place, these should load automatically. If you see any red error messages, double-check your file paths and make sure the files are named exactly as specified. Set your image size, move to Step 2, which is Image Size. Here you'll see an empty SD3 latent image node. The default settings are usually 1024 by 1024 pixels with a batch_size of 1, which means it generates one image at a time. You can adjust these values based on your needs and VRAM capacity. If you're using a smaller model variant, you might want to stick with smaller resolutions to start with. Now we get to the fun part. Step 3, which is the prompt section. You'll see 2 text encode nodes, one for the positive prompt and one for the negative prompt. In the positive prompt box, describe what you want to generate. The example in the template shows a detailed fashion photography prompt. Z-image works best with detailed descriptive prompts that specify composition, lighting, style, and subject details. The negative prompt box is where you specify what you don't want in your image. You can leave this empty if you want, but adding quality-related negative terms can sometimes improve results. Step 7, configure sampling settings. Next, you'll see the K-sampler node, which controls how the image is generated. The seed value determines randomness. You can set a specific number for reproducible results or use randomize for variety. Steps control quality versus speed. The default of 25 steps is a good starting point, but you can increase this for potentially better quality at the cost of generation time. The CFG value, which stands for Classifier-Free Guidance, controls how closely the model follows your prompt. The default of 4.0 is usually fine, but you can experiment with values between 3 and 8. The sampler_name should be set to res_multistep, and the scheduler should be simple. These are optimized settings for Z-image. Step 8, generate your image. Finally, you'll see the VAE decode node and save image node. These handle converting the latent image to a viewable format and saving it to your outputs folder. Once everything is configured, hit the Q prompt button and watch Z-image work its magic. Understanding the workflow, let me quickly explain what's happening behind the scenes. The clip text encoder processes your prompt into tokens the model can understand. Those tokens, along with the latent image representation, flow into the diffusion model, which is where the S3DIT architecture does its thing, processing everything as a unified stream. The K-sampler iteratively refines the image through the specified number of steps, and finally the VAE decodes the latent representation into the final pixel image you can view and save. Choosing the right model variant. I want to circle back to the model variants for a moment because this is really important for getting the best experience based on your hardware. If you have a high-end GPU with 16 GB or more VRAM, go for the full BF16 version for the best quality and detail. If you're working with a mid-range GPU with 8 to 12 GB VRAM, look for the FP16 variants on Hugging Face. These offer a good balance between quality and performance for lower-end systems or laptops. Check if there are quantized versions available. These might sacrifice a bit of quality but will run on your hardware without issues. Don't be afraid to experiment with different variants to find the sweet spot for your system. Now let me show you what Z-image base can really do with some different styles and prompts. Example 1, Corporate Professional Portrait. Let me generate a professional business portrait and see what we get. I'll cue this up and wow! Look how amazing and fast that is. The detail in the lighting, the professional composition, and the overall quality is incredible. This is commercial photography quality right here. Example 2, AI technology concept. Now let's try something completely different. A futuristic AI technology visualization. Hitting generate and wow! Look how amazing and fast that is. The holographic interface elements, the color palette, and the sci-fi atmosphere all came together beautifully. This shows the versatility of the model. Example 3, legal justice concept. Let's test it with legal and justice imagery, setting up the prompt and generating wow. Look how amazing and fast that is. The dramatic lighting on the gavel, the professional composition, and the authoritative mood look like something you'd see in high-end stock photography. Example 4, 3D anamorphic billboard. Now for something really impressive. A 3D anamorphic billboard advertisement. Running this prompt and wow. Look how amazing and fast that is. The realistic 3D effect breaking through the screen, the urban environment, and the sense of scale demonstrate the model's ability to handle complex commercial concepts. Example 5. High fashion portrait. Finally, let's try a haute couture fashion portrait with holographic effects. Generating now. Wow! Look how amazing and fast that is. The elegant Dior gown, the subtle holographic overlay, and the sophisticated editorial style showcase the model's capabilities for high-end creative work. Z-ImageBase represents a significant addition to the open-source AI image generation ecosystem. Now with Base available and easily accessible through ComfyUI, we have the foundation for customization and innovation. The S3DIT architecture is genuinely innovative. The bilingual text rendering solves real problems, and the parameter efficiency means more people can actually work with this model. These aren't just incremental improvements, they're meaningful advances. If you're interested in AI image generation, Z-ImageBase is definitely worth exploring. This is a fresh release with a lot of potential, and being early to experiment with it could put you ahead of the curve. Thanks so much for watching. I really appreciate you spending time with me exploring Z-ImageBase. If you found this tutorial helpful, please subscribe and hit that notification bell so you don't miss future tutorials. I've got more AI image generation content coming, including advanced prompting techniques, model comparisons, and custom workflow builds. If you have suggestions for future videos or specific models you'd like me to cover, let me know in the comments. This channel is all about exploring cutting-edge AI tools together. Thanks again, and I'll see you in the next video. Happy creating!